Hey guys, we are on Formulae simultaneous equations, and today I'm sharing my way how to derive the formula. So there are lots of formula that can be derived from like any basic ones. For example, if you consider, let's say, perimeter, you can generalize the way of how to calculate perimeter through two sides. That's the same for the area of triangle. So this formula can be derived from the basic formula, which is the area of rectangle. Is simply showing that no matter how you split your rectangle into like triangles, they will always have the half of the area of rectangle that stays for triangle. Alright, so if you go to, let's say, financial application and you want to calculate future amount that you'll have in your accounts through, let's say, n years, so depending on simple interest and compound interest, there is also the formula for that. So if you watch my series dedicated to sequences, there are actually lots of derivation there. So, and I actually show you guys how to derive the formula for arithmetic nth term for each type of sequence, whether it's arithmetic one or geometric one. So everything can be derived from some basics, and that's the main idea. Here we'll touch a little bit how to derive generally, and I'll give you a hint how to do this. So the main hints here is to first, if you're like trying to see that your formula looks like what you've got, so for example you derived, you can check on numbers. Or if you have some troubles how to derive the formula, what you can do actually, you can first set up some parameters. Instead of parameters, you'll take just some values, right, numbers. You trying to play with numbers, trying to probably get a formula that calculate the value for your target value, let's say for the area, and then you change your numbers or your parameters into actually all the variables that you have. Okay, so that's why try to play with numbers first and see what is changing in the formula, and in which elements probably stays the same, like different coefficients, different structures, so probably structure stays the same, and then you will have more understanding to generalize that. Okay, so in sequences actually we use almost the same approach. We first trying to get the main like principle how to arrange the next term, and then we come to nth general term. All right, so that was preliminary like knowledge, and I shared my in my opinion how easily to derive. And let's go to several examples there. All right, so the first example, you need to consider a rectangle and you want to derive the formula for the perimeter. Okay, so before we're doing that, let's try to set up some numbers. Let's take the length equals, let's say 4, and let's take, width, which is 2. Okay, oh, probably let's take 3. Okay, so we have length, we have width 3, and we need to derive perimeter. So we just go by definition. So perimeter in general case is just the sum of all sides. So we've got that side equal to that side. This is just by definition of rectangle, and all the two opposite sides also equal. So we've got 3 and 3, so we add those two opposite sides and we add another opposite sides. Just we go by definition. Okay, that's by def. And now what we can do, so we can probably generalize and say, okay, we have 2 3s, so that's why we can write as 2 times 3, and 2 4s, so that's why we get 2 times 4. So basically we have 2's of each size of the rectangle, of width and of length. So that's 2's common, and what we can do, we can actually factorize. So we're taking 2 out and say that in general perimeter will have the following structure. So we get 2, and instead of the rest part what left in brackets is 3 plus 4. Okay, so in general, if you say that, okay, that's A and that's B, so basically instead of 3 and 4 you will use general parameters like a and b. So by generalizing, you can say that in brackets we have a plus b, and 2 stays the same, so you multiply 2 by the sum of two sides, which is actually the width and the length of the rectangle. So that's why the general formula here is 2a plus b. Of course, you might take like a plus b plus b, but this is not like simplified version, so I consider that one as the simplest form, so we can say that this is going to be the general formula. So as you saw, I actually start from numbers, try to play with them and generalize. In this case, it's pretty easy generalizing. You don't need to play a lot with numbers, just simply to say, okay, we add width and length and multiply by 2. All right, let's go to example 2. Here you need to write the formula for the total cost, C in dollars, of a bus trip, given that fixed charge of $4 and 0.5, so have $1 per kilometer for every 20 kilometers. All right, so we are given the cost, and first we need to calculate the cost, actually write the formula for the total cost using those two parameters. So amongst the parameters we have fixed charge, which is 4, so I simply say fixed cost or fixed charge, which is $4. And we'll also have another parameter, which is $0.50 per 20 kilometers. How would you write that? So that's definitely variable cost. So you can say that this parameter is variable cost, which is $0.50 or $0.5 per, means we divide it by 20 kilometers in order to find basically unit cost of each kilometer. So we can say that variable cost might be considered as 0.5 over $20 per kilometers. All right. So clear, I hope. Okay. So that's why the total cost in dollars is going to be fixed cost. So in this case, it's $4, and we add variable cost per every 20 kilometers, which is actually 0.5 over 20, but we can calculate that variable cost in this case. Let's check it up. Just basically divide, and we've got 0.025. So we've got 0.025, and here we go, dollars per kilometer. Means per every single kilometer we need to pay just simply $0.025. Okay, so that's why if we have a trip for, let's say, not 20 but probably 100 kilometers, so we need to pay fixed cost and variable cost multiplied by number of kilometers. If I mark that as, let's say, distance, which is in kilometers, we'll get the general formula for the total cost. Okay, but here we just need to write a formula that calculates the cost for a given parameter. So I generalize very fast without plain numbers. But if you guys have like troubles with that, so try first to figure out, okay, what do you have? So first calculate with given numbers. So you have $4. You pay for just, I think, having seat in this bus, no matter where you're going, where is your destination. And you also need to pay $0.50, okay, per every 20 kilometers. So what it means is that you have $0.50 charge per 20, but it's not convenient to write, so it's better to write over 20. In this case, you'll get simply this formula, and that means that you pay 0.5 per every 20. So you need to know that that's your variable charge, okay? Variable charge. And I actually generalize using that. So your total cost in this case for given parameters, it's $4, which is fixed costs, and 0.5 is a variable charge per 20, per given 20, so your trip is 20. So you've got $4.5. That's the total cost. But that's for 20. But what if you go for like another, let's say 100? Just 5 times more, and you can say, okay, if the trip, your destination is actually 100 kilometers, so how much would you pay? So you understand that 100 kilometers is basically 5 times more than you pay for 20. So that means the general cost is going to be fixed cost $4 anyway, and you add 0.5 but 5 times, so you multiply by 5 times because you have 100 kilometers instead of 20. Okay, 0.50 or $0.5. Okay, in this case you'll get $2.5 extra on top of 4, so in total you'll get $6.5 in total. Okay, so that's the way how you can derive the formula. So but actually if you use that as the general one, so if you just highlight, in this case distance should be clearly stated in kilometers. So for example, if we use that formula for the case, we just simply write that, okay, so total cost in dollars is going to be fixed cost. If we calculate that, so $4, variable cost is going to be 0.025, so we add 0.025, and we multiply that by distance, which is in kilometers. In our case it's just 100, so you can check yourself, and if you multiply by 100 means that's going to be in dollars in total. So you just simply transfer the decimal point right there and you'll get the same answer, which is $6.5 in total. Okay, so that's an idea how you can get the right formula for those two examples. Okay, let's move next, and here we have another 2 questions or just examples. Okay, let me see. So we've got the first one. So what we need to do there, so we need to derive the formula for the amount A in person's bank account if the initial balance was $10,000 and $1,000 was deposited each month for 10 months. Okay, so what we have initial amount. Okay, so initial balance, so that's why the final balance $8 and the account $8 is going to be equal to 10,000, which is for the initial amount. That's initial amount or balance, initial balance. And on top of that, we need to add 10,000 each month for 10 months period. Okay, so what it means that we got $1,000 and we need to multiply it by 10 months because that's our period. Okay, so that's monthly deposit and over long 10 months. So that's the number of periods, number of months. Okay, in this case we'll get finally the dollars amount. It's going to be 10 times 1,000. We got 10,000, so in total we've got 20,000 in person's account. How we can generalize that formula? Again, we set up the general structure of what we saw here by observation. So we've got initial balance, so we can say initial amount A0, which is initial balance. Okay, it's A0, and on top of that we need to add monthly deposit. Let's say deposit D, which stays for monthly deposits right there. It's in this case it's 1,000, and we just multiply by number of periods, in this case number of months. Okay, so we can say number of months is just simply n. And now what we get the formula for $8 over n months periods with initial balance A0 and with each monthly deposit of $D. Okay, That's the formula that we generalize. And actually, this sort of linear dependency, right? Let's have a look how A depended on n number of periods. If each monthly deposit is the fixed amount. Yeah, that's definitely linear. Let's have a look. Y equals vice versa. So mx plus c, but I'll write in different way. So mx and c are add here. So c is simply initial amount right there. M is simply gradient. Basically, it stays for deposit amount per month. And x is the number of periods. So y from x is linear dependency, is the same as a amount from n. Okay, hope you understand that. It was pretty easy. And let's go to example 4. We need to write the formula for the total amount A in person's bank account over 10 years if the initial balance was 10,000. Okay, pretty the same, except for here we have 10 years. And annual simple interest rate have been applied to the initial balance for 10 years. All right, so it was applied for 10 years. Okay, we set up almost the same formula. So A amount in dollars is going to be, so one more time, just, wow, it looks pretty bad. Okay, I just erase one more time. Sorry for my A. One more time. So $8. Okay, $8. It's going to be A. So $8 on the account, on person's account. If we have initial balance 10,000, so we write that $10,000, and annual simple interest rate. Okay, so basically for 10 years we will use linear dependency, because in this case been applied only to the initial balance. So what we're gonna do, we need to say that interest rate, we are not getting actually interest rate. Let's set up as R, and if it's in percentage we need to divide by 100. So R over 100 is going to be rate applied to and converted to into decimals. So we've got R over 100, that basically interest rate. So interest rate, so not in percentage but in decimals, because we divide by 100, and then we need to multiply that by initial balance for a number of years, 10 years. So we apply to $10,000 and for 10 years. All right, now let's try to generalize, and we set up the following. So that's initial amount. We can even factorize that. Let's have a look. So if we factorize, we get $10,000. That's initial amount. Here we'll get 1 plus, let's say, rate in decimals. So now it's rate in decimal. Okay, decimals rate, that's still interest rate. Let's say 10%, we convert into decimal is 0.1. Okay, and we need to multiply 10 periods horizon. Okay, that's called investment horizon in the world of finance. Okay, so how we can generalize, if this is initial balance or initial amount, we can set up as A0. So that's rate as a decimal. So 10 is going to be, but you need to indicate that's rate in decimal. If rate is percentage, we need to divide by 100, and 10 number of years. So we set up like number of years, so we can set up, let's say, n number of years. How we can generalize that? Pretty easy. What we're gonna do, we just simply can say that it's well-known formula for the simple interest. And right now I'm going to generalize. So A amount in dollars is going to be, so initial amount is just A0, and here in brackets it's going to be 1 plus, let's say, rate as percentage if you like, over 100 and times number of periods. Okay, or we can use alternative formula if we already have our percentage over 100 as rate as decimal, so we can also use that one. A initial amount times 1 plus, let's say, small r times n, okay? Where small r is simply rate as percentage over 100. So that's the way you can generalize the formula. They are not complicated. Within GCSE Higher Maths and within igcse, they are be given restricted to well-known formulae, so it's less likely that you'll be given sort of like hard questions to generalize like law of physics, let's say second Newton's law, or like law of pressure in gas. That's less likely. So you'll be given similar examples and similar questions, so use that as a reference, and actually you'll succeed in this sort of questions. That was Daniel Dallas. Thank you guys. Don't forget to subscribe if you're new here. There are lots of pretty useful stuff that you can apply in your education for GCSE, igcse, and higher levels as well. So don't forget to smash the bell button to be notified on a daily basis, because every day there are new problem appears. So you'll be definitely tuned up, and that will be the food for your brains to work. All right. See you later.